Welcome to Loksatta Yashasvi Bhava. Children, you must be well versed with the first 4 topics of Standard 10th Algebra syllabus. Now, we are going to learn about the last topic of the syllabus, that is statistics. Statistics is used in every walk of life. It is used in almost all the subjects as physics, chemistry, biotechnology, agriculture, commerce, economics, sports, medicine, education, etc. It is a branch of mathematics dealing with the collection, presentation, analysis and interpretation of numerical data. We have eminent Indian statisticians like Dr. Mahalanobis, Dr. Sukhatme, Dr. Huzur Bazar and Professor Rao, who have done great work in statistics. Also children, in Standard 9th, you must have learned the basic of statistics in the form of terms like group frequency distribution, ungroup frequency distribution, primary data, secondary data, inclusive and exclusive methods of classification, class width, frequency, class mark, etc. Also, you must have gone through the 3 measures of central tendency: mean, median, mode. How to calculate mean, median, mode for ungrouped frequency distribution. So now in Standard 10, we are going to learn the following subtopics of statistics, that is mean, median, mode for the grouped frequency distribution, interrelation between the measures of central tendency, pictorial representation of statistical data, that is pie diagram, graphical representation of statistical data, that is histogram, frequency polygon, frequency curve and the ogive curves. To start with, when we learn mean, we have 3 methods of finding mean for the group frequency distribution. The first method is the direct method, second is the assumed mean method, and third is called as the step deviation method. When we are going to see the 3 methods, we are going to understand it by learning the differences of how to calculate them, but the same answer. In the direct method, the table consists of 4 columns. In the assumed mean method, which is also called as shift of origin method, we have 5 columns, and the data written in the step deviation method, which is also known as shift of origin and scale method, has 6 columns. Let us come to find the mean by the direct method. The first column has all the class intervals as been given in the sum. The second column has the corresponding class marks written. The third column consists of the frequencies once again, which is given in the sum. The fourth column, you have to find out the product of the corresponding class marks and the frequency, and then finally find the sum of all the products. So these are the 4 columns. First column with the class interval, second with the class marks, third with the frequencies, and fourth with the product. After you write all the values in all the 4 columns, you will calculate the mean by writing it as x bar, which is equal to sum of all the products of frequency and the class marks divided by the sum of all frequencies, and you would get mean by the direct method. Suppose the same sum you have to calculate mean by the assumed mean method, which would consist of 5 columns. The first 2 columns will remain the same, that is to enter the class intervals and their corresponding class marks. A little change now in the third column would be you have to find out the value of A, which would be the class mark of the middle class, and then put it in the formula of deviation, that is di is equal to xi minus A. The fourth column would be the same, that is to enter the frequencies which are given in the sum. The fifth column would be the product of these frequencies along with the deviation, and finally to find the sum. And hence as we enter the numbers in all the 5 columns, we would find out the deviation by using the formula sum of all FIDI upon sum of all frequencies. After we find the value of D dash, we find out mean by adding the value to the assumed mean, that is A. And in this way, we calculate mean by the assumed mean method. The third method, as I told you, is the step deviation method. One step ahead of it. That is, here we have to fill 6 columns. The first 2 columns would be the same, entering the class intervals and the corresponding class marks. The third column would again be the same as the assumed method to find the deviation by assuming the assumed mean. Then a fourth column would be UI, that will be equal to xi minus a upon h, where h would be the class width of each class interval. Then the fifth column would contain the frequencies as given in the sum, and the sixth column would be the product of UI and the frequencies. After you find the product for each class interval, again find out its sum. And then how to calculate the mean? The mean is calculated by first finding out the value of U bar, that is equal to sum of all Fi into Ui upon sum of all the frequencies. Once you get the value of U bar, you calculate the mean as A plus H into U, where H is the class width. And hence, we can find out the mean by any one of the 3 methods, the direct method, or the assumed mean method, or the step deviation method. Children, remember, if in case the method is enclosed in the brackets, you have to use the method prescribed. Otherwise, you can use any one of the method to solve the sum. Let us go to the merits and demerits of finding the mean. This method is very simple to understand, easy to calculate, has one and only one interpretation, and is based on all the observations. The demerits of using these methods are, it cannot be determined graphically, mean cannot be determined for open-end classes, as well as it cannot be determined by inspection. And this method is very sensitive to changes in extreme observations. Once we calculate mean, now we come to the second measure, that is finding the median. For finding median, we have to use 3 columns for entering the data. The first column would be the class intervals, which would be the class boundaries for the discontinuous class. Then the second column would be the frequency column as given in the sum. And the third column would be important here, that is to find the cumulative frequency of less than type, which also you have studied in standard 9th. Then after you fill the values in the 3 columns, use the formula for the median, which is median is equal to L. L is the lower boundary of the median class plus n upon 2 minus Cf. N is the total frequency and C is the cumulative frequency, multiplied by H upon F. H is the width of the class and frequency is the F is the frequency of the median class. Once again, after we find the median, we see the merits and the demerits. Again, the method for finding out the median is simple to understand, easy to calculate, it can be determined graphically, and this method is not affected by extreme values. Let us see some of the demerits. That is, its calculation requires arrangement of observations in ascending or descending order of magnitude, and this method is not based on all the observations. Now let us come to the third measure of central tendency, that is the mode. For finding out mode, we require to enter the data in only 2 columns, the class intervals and the frequency, mostly which has been given in the sum. You have to just enter it down properly in the 2 columns. And then find out the mode again by using the formula L plus Fm minus F1 upon 2Fm minus F1 minus F2, where again L is the lower boundary of the model class, Fm is the frequency of the model class, F1 is the frequency of the pre-model class, and F2 is the frequency of the post-model class. multiplied by h. Again, h is the width of the given class. Once again, after we find the mode, we see the merits and the demerits. Again, the merits, the method is simple to understand, easy to calculate. It can be determined graphically, which we would see it later on, and this method is not affected by extreme values. Demerits, the method is not unique. It may not exist and not based on all the observations. In this way, we can see how to calculate the mean, median and mode for group frequency distribution table. We have seen the mean, median, mode of the group frequency distribution table. Let us understand the interrelation between the measures of central tendency. This is given by the formula mean minus mode is equal to 3 into brackets mean minus median. Here you would get a series of sums where they would either give you two values, mean, median, and you have to find the mode, or mean and mode would be given and you have to find the median, or vice versa. So you have to just substitute the values in the formula mean minus mode is equal to 3 mean minus median and get the unknown value. Let us come to the pictorial representation of the data, which can be understood by the pie diagram. Pie diagram can be understood by two ways. Either you have to construct the pie diagram, or a pie diagram would be given to you. You have to read the pie diagram, understand and answer the questions which are given for the sum. What is a pie diagram? In a pie diagram, which represents a circle, the values of the components are represented by the sectors of the circles, which resembles the slices of a pie. For example, here are given the percentages of marks which are scored by a student. A student scores 85% marks in English, 85% marks in Marathi, 100% marks in mathematics and 90% marks in science, which have been given in a form of a circle, and the various sectors of it, they are the sections which understands that the child scores 85% in English or 100% in mathematics. When we have to construct a pie diagram, we have to understand that the scores which are given are to be divided or converted into the central angles for each component. Draw a circle with a convenient radius and divide the circle into the number of sectors as per the measures given. When we have to read a pie diagram, we have to just see the diagram, try to understand what are the sections being given, convert the values accordingly, and then answers the questions which are given in full sentences. After we come to the pictorial representation, let us come to the graphical representation of the statistical data. This has been given to you in three ways: histogram, frequency polygon, and the frequency curve. When we come to the first part, that is histogram, you would find that the graph is in the form of a joint bar diagram, but here you find that the bars are, the horizontal or the vertical bars are attached to the y-axis and each is joined to each other, which means that the classes are continuous. If a sum is given where the classes are discontinuous, you have to always remember to make the classes continuous and then start plotting a histogram. So the important points in plotting a histogram is, first point, making the classes continuous, which are also called as extended class intervals. Then you have to plot these extended class intervals on the x-axis, take the frequencies on the y-axis, draw rectangles on the x-axis with the base as the extended class intervals, take the height of the rectangles proportional to the corresponding frequencies, and if required, use the crink mark to use the graph paper fully. For example, here we have scores directly starting from 0, so there is a regular intervals of 30. But here we find that the first score begins from 34.5 without a regular interval, so a crink mark is being drawn on the x-axis so that the proper scale can be understood on the x-axis. Then we come to the frequency polygon or the frequency curve. For drawing a frequency polygon or a frequency curve, we may start by drawing a histogram. or we may only draw a frequency polygon or a frequency curve. For it, we have to prepare a frequency distribution table with class marks. On the x-axis, plot all the class marks. On the y-axis, plot all the frequencies. Then plot the points, that is the class marks along with the frequencies. And do not forget to plot two additional points with two additional classes. One preceding the first class with frequency 0 and the other succeeding the last class with the frequency 0. These points are common for both the frequency polygon as well as the frequency curve. Remember now, when you draw a frequency polygon, all the points are joined by straight lines and then it will be called a frequency polygon. If you use your hand and draw smooth freehand curves, it becomes a frequency curve. And that is only the difference between the frequency polygon and the frequency curve. Up till now we have seen the central measures of central tendency, that is mean, mode, median, along with the pictorial representation, that is the pie diagram, the graphical representation, that is histogram, frequency polygon and frequency curve. We come to the last part, that is the ogives or the cumulative frequency curves. This part is very well explained in the written version of the same chapter. You may go through it and understand it, because in ogive curves you may draw two curves or each curve separately. A cumulative frequency curve of less than type or cumulative frequency curve of more than type, or the mixture of both the curves drawn on the same graph. Thank you.